Good evening, folks, and Merry Christmas Eve. It is that time. It is the final Advent of Code live stream of the season. We are just under 4 minutes from this very last puzzle of the Advent season unlocking. Thank you to everyone who has hung out on these streams, who has watched these videos, who has solved these puzzles together with us. I've had a lot of fun. I hope you have too. And I hope you're having a great holiday season. So, like I said, this is going to be the last stream of the stream. As always, I'm going to be putting the code that we write up on GitHub. My GitHub repository is github.com/Craig-Chasseur/AOC2020. The stream replays will be up on YouTube. That's youtube.com/Spoonboy42. No matter where you watch this, you can find the links down in the description. As always, we're going to be working through these puzzles in C++. If you have any questions, feel free to drop them in the chat, or if you're watching the stream replay on YouTube later, feel free to ask a question in the comments there, and I will do my best to answer it for you. So, we have just a few minutes until tonight's puzzle unlocks. Why don't we go ahead and just get set up for it by putting together the scaffolding for a puzzle as we do every night. So make a new directory for day 25. Make a program in it for part 1. Have our minimal C++ program here. Add a build file so that the Bazel build system that we're using knows how to build it. Okay, and let's go ahead and build and run that right now, just to check that everything is working okay. Yep, does nothing, which is what we expect. And as we've been doing a lot of these days, we'll go ahead and, as a head start, include the check and the IO libraries that are in my repo that we use for assertions and file I/O respectively, because we need those most days. We might as well just include them to start with. Go ahead and build and run again, and we're good to go. So we now have a little over a minute before tonight's puzzle unlocks. You can see, the very circuitous route that we've taken to get to our island vacation. Now, last night's story, we got as far as the lobby of the resort that we're staying at, and we had to simulate the living art installation on the hexagonal tiles on the floor. So we had kind of a hexagonal version of something similar to the game of life, a cellular automaton. Tonight, who knows what the puzzle will be, and who knows how difficult it'll be to get our final stars and earn our very well-deserved vacation here. Just going through this year's puzzles, I have to say, I've had a lot of fun this year. I think overall, it's maybe a little bit easier than it was last year. And last year was actually the first year I did Advent of Code. But, it varies a lot, and it varies day to day. Like, I think one of the hardest puzzles was the day 20 puzzle, where we were assembling images like a jigsaw puzzle. That was also one of my favorite, because I really liked how each step from it, followed on from the last. Let's see what we have tonight. Combo breaker. You finally reached the check-in desk. Unfortunately, their registration systems are offline, and they cannot check you in. They quickly add that tech support is already on the way. They even created all the room keys this morning. You can take yours now and give them your room deposit once the system comes back online. Okay, we've got an RFID card. Rooms on the 25th floor, and the elevators are also out of service. So you have to climb the stairs and navigate the halls. Sounds like the card isn't sending the right command to unlock the door. If you go back to the check-in desk, surely someone there can reset it for you. Oh, no. 25 floors. Okay. Unfortunately for the door, we know a thing or two about cryptographic handshakes. Okay. Transforms a subject number. To transform a subject number, start with the value 1. Then a number of times called the loop size, perform the following steps. Set the value to itself multiplied by the subject number. Set the value to the remainder after dividing the value by 20, 20, 12, 27. Card always uses a specific secret loop size when it transforms a subject number. The door always uses a different secret loop size. Handshake works like this. Card transfers a subject number of 7 according to the card's secret loop size. The result is the card's public key. Door transfers a subject number of 7 according to the door's secret loop size. It's the door's public key. Card and the door use the wireless RFID signal to transmit the 2 public keys to the other device. Now the card has the door's public key and the door has the card's public key. Because you can eavesdrop on the signal, you have both public keys, but neither device's loop size. The card transfers the subject number of the door's public key according to the card's loop size, as well as the encryption key. The door transfers the subject number of the card's public key according to the door's loop size. The result is the same encryption key as the card calculated. Okay. This sounds like a version, and again, I am way out of practice on this, but this actually sounds somewhat like a version of how key exchange works, like in a Diffie-Hellman system. I mean, not something as simple as this iteration here, but the idea that you can exchange public keys either way and then develop and derive a shared secret. If you can use the 2 public keys to determine each device's loop size, you'll have enough information to calculate the secret encryption key that the card and door use to communicate. That'll let you send the unlock command directly to the door. So, the card's public key is this with a little trial and error. You can work out loop size must be 8. Then suppose you notice the door's public key is this. By the same process, you determine the size of 11. What is the encryption key the handshake is trying to establish? Okay, let's get our input here. And, this is one of those things where it's possible that the... let's go ahead and read that. It's possible that the loop size is going to be something hideously large, in which case we will have to use some sophisticated math, maybe. But maybe not. We shall see. So we can just say the value to itself multiplied by the subject number. Okay. So initial value is 1. We multiply by the subject number in each loop. So we'll just say while we multiply by the subject number. Again, just writing it the brute force way right now, and maybe we need to do something better in the future. We'll see. Get the remainder after dividing by that special string. And of course, we should iterate the count of loops. Okay. can also apply loops with the given subject number. Okay. So for each of those, we will do the same thing where we multiply the value by the subject number, and then take the remainder when dividing by 20, 20, 12, 27. Then we return the value. So for the I/O here, just to read in the numbers, we can just check 2 equals argc. So we want 2 arguments to our program, the program name itself and the input file. Read in the lines. And then we expect there to be exactly 2 for the door and the key. I'm beginning to think, though, that, these values could get big enough, the multiples could get big enough, we should maybe make these int64. So I'm just going to go ahead and do that now, just for the sake of safety, because they seem like they might get kind of big. Hopefully the loop size doesn't get too crazy, but we might as well just use standard. We might as well use int64t for everything. We can compute the private keys. Well, we won't get the private keys, but we can maybe derive the loops. Or, yeah, I guess we would. Yeah. I mean, there should always be exactly 2 here. Doesn't really specify which is the card and which is the door, but this is kind of a symmetric system, so it doesn't really matter. The subject number we start with is 7, and the result that we're looking for is the first of those public keys. And then we would say door loop size. I guess we really don't need to do both of these necessarily, but we'll see. It'll be a good check if we find that, you know, that these two agree with each other. So we apply loops to the second element, the back element from public keys, but we use the card's loop size. And we will check that doing it in the other direction produces the same result. And we can spit out the encryption key. Okay, so let's put together, let's say that the card, so we have an example that they've given us on the website, so let's just put together an example here of, to test with, where we have the card's public key is that number, and the door's public key is that number. And if we run our program on that test input, nope, that's got to do test.txt, there we go. It gives us the correct key. So let's see how it does on our actual input. Oh, okay, that ran pretty quickly. Let's see if that's our actual encryption key. Maybe this is easier to crack than we thought. All right, one gold star left, the final. The light turns green and the door unlocks. As you collapse onto the bed in your room, the pager goes off. It's an emergency. The soft serve machine has failed, and you're the only one that knows how to fix it. Dispatched a reindeer to your location. The reindeer carefully explores the contents of the room while you figure out how you're going to pay the 50 stars before we leave. Ah. Looks like we only needed 49 stars after all. You fix the soft serve machine. Santa offers you a ride in the sleigh. Maybe the resort has a chimney you can use. We did it, folks! So this last night's Christmas Eve puzzle, there's a Easter egg in at least one of these puzzles, and I will look forward to looking through these again. But we did it, folks. We saved our Christmas vacation, and it feels pretty great. Yeah. Oh, please no hurricane. Okay, that's pretty fight. So thank you all for watching the stream. Tonight's puzzle was thankfully pretty simple, and we did not have to do any fancy math to crack the encryption on our door key and get into our hotel room at the resort. I just want to say thank you, though, to everybody who watched all of these streams. Thank you to everybody who solved the puzzles along with us. A huge thank you to the creator of Advent of Code, Eric Weisel, who develops these puzzles every year as a gift to all of us to have fun with. I hope you all have some happy holidays. I hope you all learned something here. I hope you all had fun. Merry Christmas. Happy holidays. Just thank you very much. And again, you know, if you have any questions, feel free to drop them in the comments. But just, I hope you all have happy holidays and that your 2021 is better than your 2020. I think that's something we could all use. Okay. Good night, everybody. Thanks very much.